All right, here we're going to go through question 7, part B, which is again asking us to compute this iterated integral by reversing the order of integration. And so here, just like we did in part A, okay, we'll first look at the bounds. And so for y, we're letting y vary from a low bound of e to the x and a high bound of e. And then for x, we're letting x vary from 0 to 1. Okay, so to sketch a picture then of the region being described by these inequalities, I'll start by just sketching y equals e to the x, and I'm limiting myself just to 0 to 1, so I'll just draw this portion of our graph, say. This is y equals e to the x. Okay, and x varies from 0 to 1. And now y, right, has a low end of e to the x and a high end of e. And if y were equal to e, that's just going to be this horizontal line here at e. Okay, so the idea here is, okay, with the order of integration being dy dx, we fix an x between 0 and 1. So I fix an x, say, here. And then I'm going to let y vary from the low end of e to the x up to the high end of e. Okay, so for that fixed x, y varies from e to the x up to e. So I'm describing a vertical strip here. And now as I let x vary from 0 to 1, I'm going to be stacking these vertical strips, and I'm going to be filling out this region here. Okay? All right, cool. So that's a picture then of the region we're integrating over. So to switch the order of integration, I want to now think about filling out that region using horizontal strips. Okay, so I have my integrand y over the log of y, and then I want a dx dy integral now. So here what we're going to do is fix a y to start. So here's, say, a y, and then we're going to let x vary. Okay, so x is going to vary from where to where? Well, it's going to start from a low end just along the y-axis, so when x is 0, out to a high end along this exponential curve y equals e to the x. Okay, so this bound right here would be when x is 0, and then this bound right here would be what? Well, since I know that y equals e to the x, x then would equal the natural log of y. Okay, so for the bounds of integration for x, I'm going to go from 0 up to the natural log of y, and then I'm going to stack these horizontal strips as we let y vary from where to where. Well, the high bound is e. What's this low bound? The low bound is where the exponential curve intersects the y-axis. Or in other words, when x is 0, we get e to the 0, that's going to be 1. So y there's going to range from 1 up to e. Okay, so now let's see if this helps. I'm going to integrate from 1 to e, and then integrating y over log y with respect to x. See, this is all just now a constant, which is great. So I'm going to get y over log y times x, and we're letting x vary from 0 to the log of y. I got my dy there. So now plugging in log y for x and 0 for x, that's going to give us this. We're going to get y over log y times the log of y. And plugging 0 in for x just gives me 0. So I wind up here, and this is great because now these log y's drop out, and I'm left simply with integrating y from 1 to e. And that's not too bad. That's just going to be y squared over 2 from 1 to e. And so I'm going to get e squared over 2 minus a half. And you can leave it that way, or if you like, go ahead and write it as one fraction. And there we have it. All right, great. Thank you.